So we are now at part 3 of this lesson. In the first part, we went through this question right here, where we learned about signed area. Then we went through some key facts here. Then we did this question. That was fun. And now we come to the third question right here. So let's zoom in and let's give it a read. Zoom, 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 zoom. All right, so what does it say? It says, find the area bounded by the graph y equals x squared minus 4, y equals 0, and x equals negative 4. Now, the first thing that we really have to appreciate is the fact that if our area is above or below the x-axis, it's really going to affect what's going on. So we're going to have to first sketch this function to figure out whether or not the area we're considering is above or below the x-axis. So that means I'm going to have to factorize this to get it into a form that I can sketch. Y equals x squared minus 4, well, that's quite clearly a difference of squares. So it's going to be x minus 2, x plus 2. So those key foundational skills are really super duper important, so you can easily answer things like that. Because based on this, I can immediately tell you now that my x-intercepts are going to be 2 and negative 2, 2 and negative 2. I don't know why I did a semicolon there. And then my y-int, actually for this problem right here, my y-int doesn't matter, but we know what it's going to be. It's going to be negative 4, because if we let x equal 0, it will be negative 4. But it doesn't, I don't think it's going to really affect anything. We'll see as we go along. All right, so now with this information, we can give this thing a sketch. So it's going to look something like this right here. So as you can see there, I'm going through negative 2 right there, and I'm going through positive 2 right here. Perfect. Next, I need to draw y is equal to 0, and we know that y is equal to 0 is simply just the x-axis, so it's just going to look like that. And let me write that in. Let me write y is equal to 0. And let me over here write y is equal to x squared minus 4. And now we have to draw x is equal to negative 4. And we can do that very easily. We come over here. We draw this down like this. Perfect. Ooh, that's a bit wonky, but it will do. It's going to be x is equal to negative 4. Perfect. So now when we're finding the area bounded by the graph and all these things right here, it's quite clearly going to be this region right here. I might actually do this in a different color. Let's do this in green. This area right here. So hopefully that comes through a bit clearer. And also this area below my x-axis. So the area right here as well. So I've got two areas. So hopefully that is somewhat clear. There we go. Perfect. Let's label them. Let's label them A1 and let's label them A2. Now, obviously, A2 is going to be negative because it's going to be below, because it's below my x-axis, and A1 is going to be positive. Now, in the last example we went through, we found the area of A1, we found the area of A2, and we kind of approached the question in that way. We're going to do basically the same thing here, but I just want to show you that we can approach it in a slightly different way, but pretty much the same. So what I'm going to do is I'm going to say to find the area of this, what I'm going to write is the following. First, let's write down the integral that would be for this region right here. Let me just make this very clear that this will be negative 4 there. So it's going to be the integral between negative 2 and negative 4 of my function, which is x squared minus 4 dx. Perfect. So between negative 2 and negative 4, this is going to be positive. So there's nothing I have to do there. Now what we're going to do is next to it, we're going to write our area of A2. So that again is going to be the integral of 2 and negative 2, always making sure I put my bigger number up here, x squared minus 4 dx. Now here comes the tricky part. Would I put a plus here? Because it looks like I'm plussing these areas together, but I wouldn't, because this area right here is going to be negative. So that means I have to subtract them. And by doing this, this is going to tell me what my total area is going to be. So that is the tricky part right there, realizing that I need to subtract these integrals from each other, because this one right here is going to be a negative value. So putting a negative there is going to make it a positive value. So when I add them all up, everything is fine. In the previous question up here, if we go up for a moment, you can see that instead of doing it that way, I solved for A1, then I solved for A2. I still put a negative there, but I kind of treated them separately. This time I'm going to do it as one equation right there like that. But kind of, I'm still technically doing it in two parts, aren't I? So nothing that revolutionary, but I just wanted to show you a different way it could look. Okay, so once we're in this form right here, we're going to anti-differentiate that, which means I'm going to be left with x cubed over 3 minus 4x, put my square brackets, put in my terminals like that. Then I'm going to subtract, I'm going to anti-differentiate this, which is going to be the same thing, minus 4x. But my terminals are going to be different. They're going to be 2 and negative 2. The next thing that I'm going to do is sub in these things right here. So I'm going to end up with negative 2 cubed, which is going to be negative 8 over 3, plus, because I'm going to put a negative in there, and that's going to end up being 8, positive 8, because a negative in the negative. Then I'm going to do that. Then I'm going to subtract, open my bracket again. Negative 4 cubed is going to be negative 64. Oh, nearly got me there. Let me fix that up a bit. Remember, when you're cubing a negative, it stays negative. Negative 64 over 3. And as you can imagine, that's where people make mistakes. This is going to be positive 16. Put that like that. And now what I'm going to do is I'm going to do this one over here. So it's going to be minus. And what I'm going to do here, just to make sure that I realize that there's a minus here, and everything that is going on here is going to be minus. I'm just going to put a bracket on the big outside there, and hopefully that makes sense. It'll make more sense as we keep on going. As I put 2 into that, I'm going to end up with 8 over 3 minus, that's going to be 8 there, close the brackets, minus, open the brackets, negative 2 there will be negative 8 over 3. Then it's going to end up being plus 8 there because of negative and negative. All right. And then make sure I close it off like that. So I put this negative there because this whole thing is going to have to be negative. All right. What's going to happen here? Well, before I do anything else, this is really just arithmetic, and it just annoys me because this is where mistakes happen. So you're just going to be very careful you don't make any boo-boos here. So we're going to get negative 16. So I just expanded out my negative there, and then I'm going to do the same here. So this is going to be, and I might actually treat these as two separate things. So let me do that. Let me treat that as that, and that is that. So I'm going to end up with 8 over 3 minus 8 plus, because negative and negative, 8 over 3 plus 8. Oh, I made a mistake. That should be negative 8. These things happen. You've got to be careful. Ever vigilant, because that negative is distributing it out like that. Perfect. The next thing that we're going to do is we'll solve each of these. All right, so I've got negative 8 over 3 and 64 over 3. That is going to end up being 56 over 3. And I've got plus 8 and negative 16. That's going to be minus 8 right there. So let's keep that there. Then I'm going to subtract over here. What have I got? I've got 8 over 3 plus 8 over 3, which will be 16 over 3. And well, let's go up for a moment. Okay, no, I think everything's fine. 16 over 3. Then I've got minus 8 minus 8. That's going to end up being minus 16. Put a bracket there. All right, so we're continuing to go here. Right here, I'm going to have to give them common denominators to add these correctly. So it's going to be 56 over 3 minus 24 over 3. And I'm going to have to do the same thing over here. This is going to be 16 over 3. 16 times 3 is 48 over 3, like that. Then we go here. 56 minus 24 is going to be 32 over 3. Let's just keep that in brackets just for consistency's sake. Minus, bracket. This right here, 16 minus 48 is going to be minus 32 over 3. So we can just stop here for a moment and we can just reflect on this. Let's zoom out and let's have a look at our graph where we had A1 and A2. I said that we were treating them as kind of one whole here instead of our previous question, but as you can see, it still breaks down rather nicely into two sections. So what we have found is that this one right here, this is A1. So A1 here, this is going to be 32 over 3, and this would be A2. And a2 in this case, we already knew it was going to be negative. It's going to be negative 32 over 3. So they've got the same absolute value, but this one is negative. And because I put a negative here and the negative there, that means as I come to this step right here, what I'm going to be left with is 32 over 3 plus, because these negatives cancel out, 30, whoa, what an ugly 3 that was. 32 over 3. So my answer is going to be 64 over 3. Let's highlight that as yellow. Perfect. So what have we just found there? We just found the total area. So I'm going to do this, we do this. This is the total area. That is what we just found, the total area. If we wanted to find the signed area, what would the signed area be? Hopefully you can immediately see what it is. It's going to end up being, because I had 32 over 3 as one value and negative 32 over 3 as the other, my signed area would just be 0. They would end up cancelling each other out. So that's what would happen if I had treated this. So another way I could have gotten this as 0 would have been if I said, you know what, let's find the definite integral between negative 4 and 2. So I would have written it like this, 2 negative 4 of, what was the question again? X squared minus 4. X squared minus 4 dx. I would have gotten that as my signed area. If we chuck that into the calculator, that would give us a value of 0. All right, that was a long question. Hopefully everything there made sense, and I will see you in the next one.